Guru from start.
Guru Brahma, Guru Vishnu,
This side also got it.
Devo Maheshwara, Guru Sakshat Param Brahma, Tasmai Shri Guruve Namaha. Shuklam Brahma Vichara Sara Parama, Agyam Jagat Vyapini, Veeda Pustak Dharini Mamayadam, Jadyartha Kalamaham, Aste Satvik Malika Vidadati, Padmasane Sanskritam, Vande Tam Parameshwari Bhagavati, Buddhi Pradhan Saradam.
Vidyadhanam sarvadhanam pradhanam.
Vidyadhanam Sarvadhanam Pradhanam. Vidyadhanam Sarvadhanam Pradhanam. Vidyadhanam Sarvadhanam Pradhanam. Vidyadhanam Sarvadhanam Pradhanam.
Sit down. First of all, let me take attendance. Are you ready?
Yes, sir.
So, be attentive, eh? Okay. Roll number 1. Roll number 1. Where is the roll number 1? Present?
19 not lesson.
So last time who performed the class? Akiti. So today is the turn of
Nisha.
Gurung. Yeah. So let's welcome her for her Okay. Is you ready? You can go and sit there. No problem.
Today is Nisha Gurung and we are standing in front of you to teach the lesson first. Unit 2 from physics. First of all, I would like to begin my class with this chart. This is the chart of the force. Here I have written the introduction of force and inertia and superformula. First of all, we shall discuss some points, and they are rest, motion, acceleration, velocity, speed, rotation, reference point, distance, mass, and displacement. Does anyone know what is rest and motion?
Yes.
Okay, I will explain. Rest and motion. Everything in this university is in the state of motion because they are changing their position continuously with the passage of time. If we have to tell our Earth, the universe where we live, is also in the state of motion. Why? Because it rotates around the sun. Suppose this is sun and this is Earth, and here we are living. And I have told that the Earth is also in a state of motion because Earth rotates around the sun. That means it changes its position. It changes its position continuously with the passage of time. That's why Earth is in motion. Now I'm going to give some examples of rest. In this figure, we have seen some pictures like mountain, trees, and stones, and flowers, and grasses. They are not changing their position. They are at rest with this.
Why?
So, a body is said to be at rest if it does not change its position continuously with the passage of time. But a body is said to be at motion if it changes its position continuously with the passage of time. And we can say that rest and motions are the two related terms. Why? Whistle comes here. Why rest and motion are two related terms? Because suppose there is a train on the roadside and it is moving That means it is in the state of motion. Similarly, in the roadside, there is a boy standing. And we can say that he is in a state of rest because he is not changing his position. But the passengers in the bus are said to be in a state of motion because they are also changing their position. With respect to that boy who is living or who is sitting outside. I hope you have understood what is rest and motion. Have you?
Yes.
Now I am going to tell about the acceleration and velocity. I will explain them by telling the differences between acceleration and velocity. This is acceleration and this is velocity. First of all, acceleration. The rate of change in the velocity of and calculate the acceleration is final velocity minus initial velocity by time taken. And the formula to calculate the velocity is distance traveled by the body per unit time. The SI unit of the acceleration is meter per second square, whereas the velocity is SI unit is meter per second only. Now in grade 8, we have learned that there are 3 types of acceleration, and they are positive acceleration, negative acceleration, and uniform acceleration, or zero acceleration. And there are 4 types of velocity. They are uniform and non-uniform velocity, relative velocity.
The time.
We have finished rest and motion, acceleration, velocity. Now we'll talk about speed. Speed is also same to velocity. The difference is that velocity is a vector quantity. Vector quantity means the quantities having both magnitude and direction. And it is always positive, negative or zero. But speed is defined as the distance traveled by per unit time, not in a particular direction. But the formula to calculate the speed is same as the velocity. And distance and speed is a scalar quantity. Scalar quantity means the quantities having magnitude only, and it is always positive. Now we'll talk about retardation. Suppose a car is changing its position. That means there is change in velocity of body, isn't it?
Yes.
So it is called the acceleration. But road conditions, the acceleration will be decreased, and then the decrease in the acceleration of body or negative acceleration is known as the retardation. Retardation, okay? The formula to calculate the retardation is final velocity minus initial velocity by time. And the SI unit of retardation is meter per second square, same as the acceleration. I have finished all these things. Now it is left. Now it is done for reference point. Suppose this is a pole. And here is a moving car. There is a moving vehicle, okay? And if we have to compare the motion of these bodies, we have to take a reference point. And for this vehicle, this pole is a reference point. Then, what is meant by reference point? A reference point is that fixed point, that fixed place, from where we compare the motion of an object. By the help of this pole, we can take out the motion of this vehicle. So that's why this pole acts as a reference point or reference frame. Now, distance and mass and displacement. Now I'll teach you about distance, displacement and mass. Here is point A and here is point B. In this point A and in this point B, the distance is this one. This is distance and this is displacement. So, distance means the distance traveled by the body and displacement means the shortest distance. If we have to go to our home, suppose this is our home, then which point you will take? This point or this point? Why? Yes, we are correct. This is the shortest distance. This is called the displacement. So that's why if we have to go home, we'll take this point. I hope you have understood what is distance and displacement. Now I'll tell you about the mass. Doesn't no one know what is mass?
Yes.
Okay, you can take.
The amount of matter contained in a body is known as mass.
You are correct. And what is the SI unit of mass?
The SI unit of kg.
Okay, you are correct. She is absolutely correct. The mass is the total amount of matter contained in a body, and the SI unit of mass is kg, which is also known as the kilogram. I have described all these things which are needed to learn the lesson force. Now we'll come to the main topic, that is force. Suppose this book and this marker are lying on the bench, and if I have to take this book in my hand, what I have to do?
Apply the force.
Yes, I have to apply the force. If I apply a force, then only this book will come in my hand. Otherwise, it won't come in my hand. Even this marker also won't come in my hand. It's not a miracle, okay? We have to apply a certain force, then only it will come in my hand. Then what is my force? Yes, a force is an external agency which tends or tries to change the position of an object. That means from rest and motion. The device and the unit of the SI unit of force is Newton. Newton is the SI unit of force. And how this Newton is the SI unit of force, I'm going to teach you. We know that the formula to calculate the force is MA. MA stands for mass, M stands for mass, A stands for acceleration. Acceleration due to gravity. Then we know that the SI unit of mass is kg, and the SI unit of acceleration is meter per second square, and this is equals to Newton, which is the SI unit of force. Then the force acting on a body can do so many things, and they are: the force can change the position of an object, it can change the speed of the object, and it can change the direction of the object too. Samiksha, please stand up. What is the unit of force, SI unit of force in CGS system?
Dyne.
Yeah, you are correct. You can sit down. The dyne is the SI unit of force in CGS system. In CGS system, force is Newton in a SI system. So there are two units of force. One is dyne and one is Newton. am going to teach numerical problem of force and P. That is, suppose if we have to find
The time now.
a body having mass 20 kg. There is a body having the mass 20 kg and it produces the acceleration of 2 meters per second square. Then if we have to find the force, we can use the formula MA. F is equals to MA. Then 20 kg mass, we can just put, then acceleration is 2 meters per second square. Then if you multiply this, it will become 40 Newton. Now the force is finished. Now we'll talk about the inertia. Inertia. Does anyone know what is inertia?
Yes.
You can stand and tell. You just find the now. Inertia is the tendency of the body due to which it unless an external agency or force acts on it. And inertia may show itself in three forms. And they are inertia of rest, inertia of motion, and inertia of direction. In this inertia of rest, the body tends to remain in its original state of rest. And in this inertia of motion, it tends to be in a state of motion. But in the inertia of direction, the body tends or tries to remain in the inertia of direction, the body wants to maintain its direction. And we can say that there is a relationship between mass and inertia. The relationship between the inertia and mass is that greater the mass of body, greater the inertia of that body. The relationship between the inertia and the mass is that greater the mass of body, greater the inertia of bodies. Now the inertia is also finished. Now I'm going to talk about the momentum. Does anyone know what is momentum?
Yes, ma'am.
Okay, that's fine. Now I'll tell you about the momentum. The product of mass and velocity of body is known as the momentum. Momentum is denoted by V and mass and V. This is momentum, this is mass, and this is velocity. So the product of mass and velocity is known as the momentum. Suppose here is vehicle A. This is vehicle A. And this is vehicle B. And this has the mass of 100 kg, and this vehicle will have 20 kg mass. Then it has a speed. The speed of this vehicle A is 20 meter per second, and this has a speed of 20 meter. That means this vehicle A and vehicle B have same speed, that is 20 meter per second. And this vehicle A have 100 kg mass and vehicle B have 20 kg mass. Then I'll ask you one question. Which vehicle is easy for us to stop and which one is hard?
Vehicle 20 is easy.
Yes. Why not vehicle A?
Because it has heavy.
Yes. The mass affects the momentum of bodies. From this example, we can say that the mass affects the momentum of bodies. I hope you understood this.
Yes, ma'am.
I have told about the momentum, inertia, and force. Now I'll tell you about the Newton's laws of motion. Newton's laws of motion. There are 3 laws of motion, and they are Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Sir Isaac Newton was an English, physics, and mathematician. He formulated the 3 laws of motion. They are Newton's laws of motion. Newton was a very great scientist of that period. So, I will tell you about the Newton's laws of motion. He had formulated 3 laws of motion. First laws, second laws, and 3 laws, third laws. The first laws of Newton state that every body continues to be in a state of rest or uniform motion along a straight line unless an external force acts on it. So the definition of the inertia and the Newton's first law of motion is same. So that's why you can tell that the laws of inertia is also same as the laws of Newton's first law. Now I'll tell you about the second laws of Newton of force. The second laws of force of this is motion, okay? Please don't laugh. Everyone does mistake, even the God does mistake, then I'm not a God, I'm your just friend. So no need to laugh, there's no joking, I'm not joking. We can tell that force also, it doesn't matter, okay? Now Newton's second law of motion states that acceleration in a body is directly proportional to the force and inversely proportional to the mass. This is Newton's second law of motion. The acceleration produced in a body is directly proportional to the force and inversely proportional to the mass. Now the Newton's third law of motion says that to every action there is an equal or opposite reaction. This Newton's third law of motion is used in our day-to-day life. Suppose in the boat, in balloon, if we have to balloon, we have to use the Newton's third law of motion. In rocket, these are the applications of Newton's third laws of motion. Very question for you. Do you know how to derive F is equals to ma? Then I'll teach you, okay? Here is the body and here is the body. Then this is initial momentum. This is initial momentum and this is final momentum. This is final momentum and that is initial momentum. And this is time. I want you to watch. This is also very much important. Initial momentum. I'm sorry, I'm going to teach other one. I forgot that this is the wrong one. Before that, I want to ask a question for you. You just state the Newton's second law of motion, okay? You please that define it.
The second law of motion says that the acceleration of the body is inversely proportional to its mass and directly proportional to its mass and inversely proportional to its force.
We know that acceleration, so we can say that A is equals to F by m, where K is a constant weight. I hope you have understood this. Now at last I will teach you how to derive Subhat formula. I'll teach you how to derive Subhat formula. S stands for distance, displacement. T stands for time taken. A stands for acceleration. V stands for final velocity. And U stands for initial velocity. There are four equations of uniform acceleration. First one is V is equals to U plus AT, and second one is S is equals to UT plus half AT square. The third one is S is equals to U plus V by 2 times T. And the last one is V square is equals to U square plus 2AS. I'll teach you how to derive these four equations of uniform acceleration. First one is V is equals to U plus AT. Okay, here is a body having the acceleration h times t, initial velocity u, final velocity v. So by the formula of acceleration, we can say that a is equals to v minus u by t. This t will multiply a, so at is equals to v minus u, or u is equals to v is equals to uniform acceleration can be derived by, we know that the average velocity can be defined as average velocity is equals to u plus v by 2, and the formula of average velocity is s by t. So now by using this formula and the definition of average velocity, I will teach you how to derive this formula. Here we have told the average velocity is defined as the arithmetic mean of initial and final velocity, and then average velocity is equals to distance traveled by the time taken also. So that's why I'm writing average velocity is equals to u plus v by 2, average velocity is equals to s by t, and then if you put this as here, and then the definition of average velocity here, and then find then this formula is derived. I'll teach you. Now I'm going to teach about b square is equals to u square plus 2as. From the first equation of motion, equation of uniform acceleration, the first equation of uniform acceleration is equal to u is equals to v is equals to u plus at. Then squaring on both sides, squaring on both sides, we get v square is equals to u plus at whole square. Roman, please stand up. Please state the Newton's first law of motion.
Uniform motion along on a straight line unless an action or force is applied.
Yes. Yes, now we are going to this. We are going to solve this. Now here is coming v square is equals to u plus at whole square. Then v square is equals to u. The formula of one of the student stand up and tell the formula of this a plus b whole square.
A square plus 2ab plus b square.
Okay. Then now we'll use this formula in this equation of uniform acceleration. Here comes plus 8t square equals to, then here a is common in this both terms, so that's why we write, but we will not write. We don't have to write it here. This because we need this t something. A square, t square. We don't write. Now here